Okay, good evening, class. Today we're going to be talking about arithmetic and geometric sequences. Um, I'm sorry, this PowerPoint should say sequences instead of sequence, so I'll change that for you. So please open up your notebooks and to a clean page, write this heading and take notes along with the video. Okay? All right, so we're going to start with an arithmetic sequence. An arithmetic sequence can be modeled by a linear function, and if we remember, a linear function is a function that when we graph it, it makes a line, yeah, and it is of the form y equals mx plus b, if we recall, right, or f of x equals mx plus b, okay? And it's a pattern that decreases or increases at a constant rate, right? And when we talked about linear functions, we talked about how they increase or decrease at a constant rate, and that rate was known as the slope, okay? When we're talking about sequences, it's known as the common difference, but it's more or less the same thing, okay? So if I look at this first sequence, it says 3, 5, 7, 9, 11. And it would continue on to say 13, 15, 17, and on to infinity. And we can see that the common difference is positive 2 because each time we are adding positive 2, okay, to the sequence. If we look at this next sequence, all right, we will see that this sequence is actually decreasing. And it looks like I made a little mistake here on the PowerPoint. Because 33 plus 2 is clearly not 29. So the common difference here would not be positive 2, but would in fact be negative 4. Right? So we're going to go ahead and change that. It should say negative 4. And each of these it should say negative 4. 33 minus 4 is 29. 29 minus 4 is 25. 21 minus 4 is 17, and so on. Okay, so in our first arithmetic sequence, the common difference was 2, positive 2. We added 2 to each term, okay, and in our second one, the common difference was negative 4. Okay, and we generally talk about the common difference using the variable d. Okay, so let's take a look at an example. Actually, before we do the example, we'll talk about the formula for the nth term, finding the nth term of an arithmetic sequence. It's given by this formula: a sub n is equal to a sub 1 plus n minus 1 times d. And this is actually more or less the formula for a linear function, right? A sub n is f of x, or y, right, is equal to a sub 1, and in that case, really, that's b, that's our starting point, right, plus the term before, right, and the slope, and the term before is x, actually, so kind of like dx, where d is kind of like the slope, okay? If that doesn't make a lot of sense to you, don't worry. I think the further we get into it, it will make more sense. So, for example, in this sequence, we have 3, 5, 7, 9. This is our a sub 1 term, our a sub 2 term, our a sub 3 term, and our a sub 4 term. Yeah. So when n is 1, we think about a sub n, and that's 3. When n is 2, we can use the formula a sub 1, or 3, plus n minus 1, or 1, because n is 2, times the common difference, which is 2. 3 plus 1 times 2, which is 5. The next one would be 3 plus 2 times 2, which is 7. And 3 plus 3 times 2, which is 9, and so on. And it follows that pattern. Okay, so let's see how we can actually use this. All right, so example 1 says, write an equation for the nth term of the arithmetic sequence, negative 12, negative 8, negative 4, and 0. So the first thing that we need to do is find the common difference. All right, so I'm going to take a look at this, this sequence here and try to find the common difference. And I can see that the function is decreasing, so our common difference is definitely going to be negative. So from negative 12 to negative 8, we subtract 4. So negative 4. From negative 8 to negative 4, we are also going to, excuse me, it's not negative 4, it is positive 4. It's increasing. So negative 12 plus 4 is negative 8. Negative 8 plus 4 is negative 4. Negative 4 plus 4 is 0. So our common difference is positive 4, right? And now we need to write an equation. So we're going to actually just use that formula and substitute what we know into the formula in order to find our equation. So our formula says a sub n, right, is equal to a sub 1, which we know is negative 12, plus n minus 1 times our common difference, which is 4. Okay, so now we have a sub n is equal to negative 12 plus, I'm going to use the distributive property, 4n minus 4. 4n minus 4. And then I'm going to simplify. So a sub n is equal to, let's see, negative 12 minus 4 is going to be negative 16. So 4n minus 16. Okay? And then we can use this formula, which is the answer to our first part, to find the nth term of the sequence. We can use that formula to find the nth term of this, not the nth term, the ninth term of the sequence. So I start with my formula, a sub n equals 4n minus 16. All right, now I want to find the ninth term. So instead of n, I'm going to substitute in 9, right? So I know my n is 9. So now I have a sub 9, right? A sub 9 is going to be equal to 4 times 9 minus 16. Substitute in 9. 4 times 9 minus 16. Okay, and then we just do that math, right? So 4 times 9 is 36. Minus 16 is going to give us 10. So now we know that the ninth term, or a sub 9, is equal to 10 in this sequence. And finally, we can think about this. Like I said, an arithmetic sequence is really just like a linear function. So we can actually go ahead and graph it if we wanted to. So we would start here where n is 1, 2, 3, 4, and then 5, and we just use our formula for a sub n for n minus 16. So in the first part, we've got 4 times 1 minus 16. 4 minus 16 is going to give us negative 12. So now we have the point 1, negative 12. Then I can do 4 times 2 minus 16, or 8 minus 16, which is negative 8. So our point there is 2, negative 8. And 4 times 3 minus 16, 12 minus 16 is negative 4. It's going to give us 3, negative 4. 4 times 4 minus 16, 16 minus 16 is 0. So 4, 0. And then 4 times 5 minus 16, or 20 minus 16, which is positive 4. So 5 comma 4. And then we can go ahead and put these onto the graph, right? 1, negative 12 is actually going to kind of be down here. It kind of goes off our graph a little bit. That's okay. 2, negative 8 is right here. Wait, 1, 2, 3, 4, 5, 6, 7, 8, yeah. Okay. 3, negative 4 is right here. 4, 0, of course, is here. And 5, 4 is right here. And you can see that this guy is making a line because all arithmetic sequences are linear. Okay? All right. Now let's look at geometric sequences. And geometric sequences are exponential. Okay, so a geometric sequence can be modeled with an exponential function, and it's a pattern created by multiplying, whereas in the linear function we were adding. In this geometric sequence or exponential function, we're multiplying, not by a common difference, but by a common ratio. And we generally refer to the common ratio using the variable r. Okay, so if we look at our first sequence, 1, -4, 16, -64, we can see that we are multiplying by -4. So our r is equal to -4. 1 times -4 is -4. -4 times 16 is, -4 times -4 is positive 16. 16 times -4 is -16, and so on. If we're looking down here, we can see that our sequence is decreasing. So rather than multiplying by a number that's bigger than 1, we're going to multiply by a fraction. And in this case, that fraction is 1/3. 9 times 1/3 is 3. 3 times 1/3 is 1, and so on. Okay, so we are multiplying, not adding, in a geometric sequence. Okay. So let's take a look at an example. This one says, find the next 3 terms in the geometric sequence. -3, 15, -75, and 375. So the first thing that we have to do is find the common ratio. Okay, and it may actually be fairly obvious to you what the common ratio is, but we're going to go ahead and do it out properly so that when and if it isn't obvious to you, you can figure it out. So basically what you do is, to find the common ratio, you start with really the second term, and you make a ratio using the second term and the term before it, the first term. So 15 divided by -3 is going to give us positive 5. Okay, and then we're going to go ahead and do the same thing with the next one. So if we do have a geometric sequence, we're going to find a pattern, right? So I look at -75. I'm going to divide that by 15. -75 divided by 15, excuse me, that should have been a -5, shouldn't it have, is also going to give us -5. And then finally, if we look at the last one, we take the 375 and we divide it by -75, we are going to get also -5. So we can see here that our common ratio is -5, right? So now that I have r is equal to -5, I know that I'm just multiplying by -5 each time. So I can find the next 3 terms very easily. So let me go ahead and do that. So I've got, for the 1, 2, 3, 4th term, I already know, so I'm looking for the 5th term, a sub 5. All right, I'm going to take the term before it, which is 375. I'm going to multiply it by my common ratio, which is -5. And I'm going to end up with what number? I'm going to go ahead and do that on my calculator. 375 times -5 is -1875, right? I'm going to do the same thing for a sub 6. So now I start with -1875, and I'm going to multiply that guy by the common ratio, which is -5, and I'm going to get a rather large number. 1875 times -5, that's going to give us 9,375. And then a sub 7, of course, I take my 9,375 and I'm going to multiply it by my common ratio of -5. And I'm going to get a negative number, rather large negative number, negative 46,000. Whoops, I want to be in black. Negative 46,875. Yeah, and those are the next 3 terms in the geometric sequence. Okay, now let's take a look at how to find the nth term of a geometric sequence using a formula. Whoa, what happened? Hold on, sorry guys. And that formula is a sub n is equal to a sub 1 times r, which is the common ratio, to the power of n minus 1. Okay, this is exponential again, so we are going to be multiplying by powers here. So for example, when I'm looking at the sequence 1, negative 4, positive 16, negative 64, I can use this pattern. Looks like I made another little mistake here on the PowerPoint. This should actually have, rather than the arithmetic sequence formula, the geometric sequence formula, or a sub 1 times r to the n minus 1, right? Okay, so we've got that sorted. I'm going to start with my first term, which is just 1, and then I'm going to go from my first term to my second term by taking the 1 and multiplying that by my common ratio of negative 4 to the power of 1. That's going to give me negative 4. For the third term, I take my 1, still always starting here with the 1, and multiplying this time by negative 4 to the power of 2, which is going to give me positive 16. Then again, with 1 times negative 4 to the power of 3, which is going to give me negative 64. Okay? And we can use this formula in order to write an equation for the nth term of a geometric sequence. So in this sequence, example 3, it says write an equation for the nth term of the sequence negative 6, 12, negative 24, and then 48. So the first thing we have to do is find our common ratio. We do that by making those divisions, which is what I showed you in the last problem. 12 divided by negative 6 is going to give us negative 2. Negative 24 divided by 12 is also going to give us negative 2. And, of course, 48 divided by negative 24 is going to give us negative 2 as well. Sorry, that's a bit messy. So we can see here that our common ratio, or r, is equal to negative 2. So now I start with my formula. A sub n is equal to a sub 1, a sub 1 times r to the power of n minus 1. Okay, so now I have a sub n is equal to negative 6 times negative 2 to the power of n minus 1. And there is my formula. I can then use that to find the 9th term of the sequence. A sub n is equal to negative 6 times negative 2 to the power of n minus 1. And in this case, I want to use n is equal to 9. So a sub 9 is equal to negative 6 times negative 2 to the power of 9 minus 1. It's going to be negative 6 times negative 2 to the power of 8, right? Negative 2 to the power of 8, we know that's going to be positive. 2 to the power of 8 is 256. So now we've got negative 6 times 256, and that is going to give us negative 1536. And there's your answer. A sub 9 is equal to negative 1536. Okay, hopefully you enjoyed this video. Hopefully you learned something, and I will see you in class next time. Good night.